Let's talk about alcohol for a moment. It's not an essential nutrient, but it is a nutrient that is consumed by a substantial proportion of the New Zealand and world population. Not only that, but it can, and for many does, have a profound impact on short-term function, so during consumption or with very recent consumption, and also long-term health, so accumulated damage from consumption over a long period of time. And that is what makes it highly relevant to public health. It's really the ill effects. Spoiler alert, in case you haven't noticed already, I'm going to tell you that the idea of alcohol being healthy in moderation, as in health promoting in moderation, is very likely wrong. Back when I was doing my master's, which is quite some time ago, one of the projects was to look at the evidence linking alcohol with health and disease. Numerous observational studies at the time showed a U or a J-shaped curve. What basically suggested that a moderate amount of alcohol was better than none, whereas after you get past the moderate amount, you get more and more harm, more and more disease, more and more loss of life, and so on, which probably makes sense to you. What bothered me is where that curve lay, where moderate was, the supposedly somewhat health-promoting amount of alcohol varied a lot between studies, between countries. And it made me think that it may not be the substance, ethanol, that is the alcohol that we consume, if you like, the active ingredient is ethanol. I was unconvinced that it was the ethanol having any beneficial effect, because the benefit was at different points depending on what population you looked at. Now that's not impossible, but it also opens up the possibility that maybe it was just a normal amount of alcohol that was consumed by most people in a given population, in a given country, and those who weren't doing it had their reasons for not doing so, right? And may therefore not have been part of that normal group and benefited in the normal way. So I thought, well, maybe ethanol is a surrogate for something else. It's not the cause, it's just that it's very closely linked to this slight benefit in health. Being sociable can be beneficial to health, certainly better than being lonely. Now, just to note, I've already been a little bit negative, and I will continue to be in terms of alcohol. I do occasionally consume alcohol myself, and I'm not coming at this from a strong predetermined anti-alcohol stance. I've looked at the recent evidence and updated my own knowledge in the area, consistent with teaching this module. We're going to be looking at alcohol dose, so let's go over that now. The research and public health messages tend to talk about units of alcohol, often converted into standard drinks. After all, different beverages contain different concentrations of alcohol. Wine has more than beer, and vodka more than wine, for example. The New Zealand Ministry of Health uses the term standard drink, which they define as 10 grams of ethanol. And that basically gives us these: about 100 mils of wine, 255 mils of cider at 5%, 330 mils of beer at 4%, 30 mil of spirit, so shot basically, at 40%, and then about 100 mils of ready to drink spirit plus some non-alcoholic beverage mix. Now, okay, cider, that might be a reasonable amount. Beer, same thing, reasonable amount of beer. A shot, it's pretty standard, but not many people are going to have only 180 ml of ready to drink, given that normally comes in 330 ml cans, nor are they going to only have 100 mils of wine. That's not even a standard glass. So we need to be very clear on what a standard drink is, because some sometimes that is quite an atypical amount in terms of a real alcoholic beverage. The research tends to look at average standard drinks per week. So let's say that was 7 standard drinks for some people. That might look like a drink per day. For others, it may be 7 standard drinks on a weekend day or some other variation. That gives an average of 7 standard drinks. There really isn't the data to tease out the effects of the different variations. Does it make a difference if I space out my drinks, 1 per evening, or I have a bit of high alcohol consumption one day on the weekend? Maybe it makes a difference. Acutely it does. In the moment it does. That 1 drink probably isn't going to make much of a difference to my function. 7 drinks, if we're talking about me, I guarantee you, is, well, I don't think I'd be functional quite personally. But some people are only moderately impaired at that point. We don't really know the long-term effect of those different approaches. So we're going to go by averages because that's what the research has done. It's also fair to say that not everyone is going to be honest about their alcohol intake, any more than their food intake, right? Their water intake, amount of exercise they do. There are some objective tests. You can do blood tests, but they are only capable of identifying people with probable alcohol abuse problems. So those tests only really work if the intake was substantial and recent. I mean, yes, we could breathalyze people on a regular basis for a while. I don't think anyone has done that kind of study, so that would give us a bit more of a quantitative view. But generally, these studies are done as surveys. They ask people what they drink, and then they average. So, although clearly not essential, ethanol is a nutrient of sorts. We can use it to produce adenosine triphosphate, or rather, we can use it to resynthesize adenosine triphosphate, otherwise known as ATP, and often called the energy currency of the cell. Also, the harms of alcohol are not all down to ethanol itself, but also to what our bodies, specifically our liver, turns alcohol into. And to understand this, we need some appreciation of the metabolism of ethanol. Bear with me here, this is the only biochemistry I'll cover for alcohol. This graphic is a little more detailed than necessary, so I'll highlight the key points. The first step in breaking down ethanol, something that predominantly happens in the liver, we predominantly break down ethanol in the liver, is that the ethanol is converted to a substance called acetaldehyde. Now you may recognize the name of different parts of the cell in this graphic, and if you've done any chemistry or biochemistry, you might notice that different enzymes, so different biological catalysts, can get involved in this process. But what matters is that we always first get acetaldehyde. And that's bad news because acetaldehyde is more toxic than ethanol itself. Even the conversion of ethanol to acetaldehyde uses up precious resources in the cell and thereby reduces the other important activities of the cell. And in the case of liver cells, there are many. No need to go into much detail here. However, now we have a worse toxin. What happens next? Well, ideally, that acetaldehyde is converted to something called acetate. That also uses up some cell resources, but at least acetate can be used by the liver. It can be used to generate energy, among other things. But some acetaldehyde will end up in the circulation and therefore affect the rest of the body. People do vary considerably in their capacity to convert acetaldehyde to acetate, and that accounts for a lot of the differences we see in different people's responses to alcohol. Keep in mind though, ethanol itself is a toxin, so seemingly handling alcohol well is not an indication that it isn't doing any harm. If you've ever seen someone go from tipsy to obviously drunk, it will come as no surprise that ethanol and its metabolite acetaldehyde affect the nervous system. What your experience may not have already taught you is that there are less obvious long-term effects on the nervous system, even when alcohol is consumed in amounts that don't lead to drunken behavior. As the more immediate effects of alcohol are also more obvious, I'm going to skip those and look at the not so obvious. First, a tiny bit of anatomy. We divide the brain into grey matter. The grey matter is the body of the nerve cell or of the neuron. And we divide the brain into white matter. White matter is the axons, the cables, if you like, or the wiring that connects nerve cells. It's been known for a long time that high alcohol consumption over a prolonged period is bad for the brain. Now, thanks to a study published in 2022, we have some evidence of what happens to the brain at lower alcohol intakes. Basically, what this study shows is that alcohol intakes of as little as 1 to 2 standard drinks per day, so 10 to 20 mils of ethanol per day on average, doesn't necessarily mean the person drank every day, but on average, these intakes were associated with a decrease in both grey matter, so cell mass, neuron cell mass, nerve cell mass, and white matter. And this reduction is bigger at higher intakes. Perhaps no surprises there, of say 2 to 3 standard drinks per day. Keep in mind that that's still only about a glass of wine. Now, it is important to acknowledge that correlation, two things seemingly being mathematically associated, does not guarantee causation, one thing leading to the other. But given what we know from experimental studies in humans and in non-human models, and experimental studies do provide evidence for cause and effect, it is very likely that these findings of reduced grey matter, reduced white matter, even at relatively modest intakes of alcohol, are causal, as in it is the alcohol consumption it is the alcohol consumption causing the change. And the change is not just structural, but also functional. For example, regular alcohol intake is linked to greater excitability of the nervous system and therefore more anxiety. Someone who regularly consumes alcohol has a tendency to be more easily stressed. Well, that's the brain. What about more broadly? Well, a meta-analysis published in 2023 looked at alcohol consumption and all-cause mortality. Let's unpack those terms before we look at the findings. A meta-analysis is a statistical reanalysis of multiple studies. In this case, 107 relevant studies. You can think of this as a way of treating multiple studies as if they were one bigger study. All else being equal, data from more people increases our confidence in the findings. All-cause mortality means exactly what it sounds like: death from all causes, specifically within some time frame, as mortality is an inevitable outcome of life. All-cause mortality is a way of getting around the problem that one thing, in this case we're looking at alcohol, may have some benefits in one area of health but be harmful in others. All-cause mortality tells us if overall something is more good than bad or more bad than good. Now let's unpack the table a little. Everyone was compared to lifetime non-drinkers. RR stands for relative risk. In this case, the risk of death within a set time frame of different groups compared to non-drinkers. A relative risk of 1 means the same risk. So if a group got 1, it would be saying that this group has the same or cause mortality as non-drinkers. A number below 1 would mean there is less risk, so ultimately people are better off, and above 1 means there is greater risk. The 95% CI, refers to the 95% confidence intervals. These give us an indication of uncertainty. The 95% confidence interval is saying that we can be 95% confident, or 95% sure if you like, that the true relative risk is between the smaller and the larger number. Alcohol consumption in the leftmost column is in grams of ethanol per day. If you have a close look, you'll notice that there are multiple columns with essentially the same information, relative risk with confidence intervals. But there are multiple columns, and that's largely because this is observational data, meaning that people did what they did rather than being randomized into different groups in an experimental setting. So again, we cannot be absolutely sure about cause and effect. All we get from this is correlation. For example, maybe on average people who choose to drink more alcohol also exercise less, smoke more, and or eat a more nutrient deficient diet. Researchers try and account for this with statistical analyses. And that is why you see multiple columns labeled unadjusted, meaning the numbers are just taken at face value. There is a partially adjusted column, which factors in some things like that these were from different studies. And then there is what they call fully adjusted. That's probably not the best of names. It can't possibly be adjusted for everything, but that is adjusting for any number of factors that may explain the result other than alcohol consumption. It's the partially adjusted column that I'm going to emphasize, but you're welcome to look through all of them, and you'll see that there are some differences, but there's also a lot of overlap. This column is really the one suggesting an increase of harm, an increase of risk of death specifically, from even fairly modest intakes of alcohol. And again, recall, this is not one study. This is a reanalysis and a pooling of many, many studies looking at this issue from all around the world. What this paper really does is cast serious doubt on the earlier interpretations of the data, which led some to suggest a net benefit of moderate alcohol intakes. Now, although some of the analysis does not clearly show harm of lower intakes, the brain scans suggest, and the biochemistry tells us, that alcohol is most accurately thought of as a toxin. Now, alcohol does get used as a sleep aid, so it's worth mentioning the effects on sleep. These effects are going to vary somewhat by context and dose of alcohol, of course. But the focus here in this module is not on alcoholism, which clearly has numerous negative consequences. One of those is impaired sleep with insomnia, excessive daytime sleepiness, and altered sleep architecture. Insomnia is basically trouble falling asleep, staying asleep sufficiently long, or otherwise experiencing poor sleep quality, especially on a regular basis. Sleep architecture we will briefly touch on. If you've observed someone sleep for a lengthy period of time, you may have noticed that they went through different levels of activity. And that's because sleep isn't just one thing. It occurs in stages and is made up of cycles. We normally go through different stages in each sleep cycle. But both the length of a complete cycle and how long is spent in each stage changes throughout sleep, throughout the night. And it's this change in sleep cycles and moving from stage to stage, how long we spend in each stage, that is referred to as sleep architecture. Just for an example, REM stands for rapid eye movement. This is when we tend to dream. So-called N1 and N2 sleep are light sleep, and these are easier to wake up from. And N3 is deep sleep, harder to wake up from. If you do wake up from it, you're less likely to feel rested. You're more likely to be quite groggy. Different things happen during different stages, meaning different types of memory get consolidated. Motor memory, so movement, versus memory of facts or language. For example, different aspects of healing happen at different stages. So something might help us get to sleep, but then mess up the sleep architecture. And that's essentially what alcohol does. Yes, alcohol can help reduce the time between when we lay down and when we fall asleep, but it changes the quality of that sleep, and on the whole, for the worse. Alcohol also interferes with recovery from exercise by inhibiting muscle protein synthesis. Studies looking at the interaction with exercise, as in the interaction of alcohol with exercise, vary considerably in terms of the dose used, the timing used, the effects measured, and they've reported a mix of findings, with alcohol sometimes resulting in impaired future performance or impaired recovery, and sometimes having a largely neutral effect. I've yet to come across convincing evidence of benefit though. So we can safely say that the prudent thing is to avoid alcohol if your goal is to maximize performance, motor learning, or recovery from exercise. This was a look at alcohol from a very much individualistic perspective. But of course, many of the harms of alcohol are social in nature. And by that, I mean that they involve harm to people other than the person consuming alcohol. On an individual level, certainly, the take-home message here is that although earlier observational studies suggested a potential health benefit to consuming modest amounts of alcohol, reanalysis of that work, more recent research, and the majority of experimental studies do not support a benefit at any dose. Alcohol is certainly one example that everything in moderation is not always good advice. Now, sure, there may be some perceived benefits to alcohol in terms of social bonding, for example, and infrequent low-dose alcohol consumption may very well not carry long-term detectable harm. I mean, the harm might be at such a small level that it's almost neither here nor there. But alcohol is far from benign, and any benefits, real or perceived, can be achieved in other ways. So really the second message I want you to take home from this is that there is no clear, safe dose of alcohol, a dose below which we can be very confident there are no ill effects. We don't have such a dose.